welcome to Drona Edu. So as you know, myself Madhushree and I'll be taking for mathematics. So today we're going to deal with a very interesting topic which is called as a real number, right? Yes. So we're going to see more depth about this real number and then we're going to solve a few problems on that. But before that, we need to know some basic information about this real number, right? Some basic definitions and what are the topics which it includes. So what exactly is real number? So a real number is nothing but it's a collection of a rational number and an irrational number, right? Yes. See, the collection of both rational number and irrational number is said to be the what? Is said to be the real number. And then, so what is rational number and what is irrational number? See, rational number is nothing but the number which can be expressed in the form of P by Q. Okay, where the Q, the denominator is not equals to 0. Then I can say it is a rational number. For example, if I consider a number like 2 by 3, so this is also a rational number where this Q means denominator is not equals to 0. Then you may say, so then what's the actual difference between the rational number and the fraction? Because even the fraction also I can write in the form of 2 by 3. Then what's the actual difference between them? See, for rational number also we can write in P by Q form. For fraction also we can write in A by B form. But there is a difference. What is that? Here A and B, which is this, are whole numbers. Whereas the P by Q are the integers. Got it? So this is the major difference I can say. Here it is a integer, here it is a whole numbers. Likewise, we can differentiate, right? And then, what is irrational number? See, the irrational number is nothing but the number which cannot be written in the form of P by Q. For example, I have taken here, it is a 0.33, or I can also write it as a 0.26, or it may be 0.313. All these numbers are irrational number. Now there is another question. So what is that? Then what's the difference between the irrational number and the decimal number? See, this number can also be said as a decimal number, right? Yeah. Then what exactly is the difference? See, there is a common difference actually. It's very easy. What is that? See, we know that for an irrational number, we cannot write in the form of P by Q. Right? So this number cannot be written in the form of 33 by 100. But for the decimal, we can convert into the fraction. Right? So for 0.33, I can write in the form of 33 by 100 for the decimal number. But for the irrational number, we cannot write like that. So that's a difference. Okay, from this we got to know the basic about the real numbers, right? Yeah. And then the main topic here we got to study is about the Euclid division algorithm. Okay, so let's see what is that Euclid division algorithm is. See, in this we know the division. It's a mathematical operation. And the Euclid is nothing but is a mathematician who created this algorithm. But what is the algorithm? So what definition I can say? See, for example, if you have seen any instant food, okay, like a puliyogre, Maggi, or a mixed idli, right, rava idli, there behind the packet you can observe there will be a steps given, right? See, I have taken here, you can observe there is a steps given here how to prepare a mixed or a rava idli, right? So likewise, even for the Maggi, even for the puliyogre, all for this they will give, right? So the steps involved is nothing but the algorithm. Okay, so with that I can say it is nothing but Euclid division algorithm. And there is one more interesting topic which is called as a Euclid division. What is this Euclid division lemma is? So this Euclid division lemma, in this the division we know, it's a mathematical operation. So Euclid is nothing but is a mathematician who created this lemma. So we need to know what this lemma is. Okay, so the lemma is nothing but for given one statement, we can make another statement. For example, I have taken here, see my favorite color is black. Okay, in this I can also say that, and the eye color, my eye color of a lid is black. Right, from one statement I made another statement. Or you can also say the sun rise at the east, the sun set at the west. Right? Yes. So from this there is an interconnection. You can observe. What's that? See, here also the Euclid is there. Even in this also Euclid is there. So what he did, he created a statement, so which is a lemma. With that statement he made a algorithm. Okay, so that is an interconnection between this. They both are like brothers. Okay, so they both are interconnected. So let's see how they are interconnected. Yes, see, for that interconnection we are going to get a theorem which is 8.1. So this is nothing but a Euclid division lemma. So this is a statement. With this he created a algorithm. What algorithm? A division algorithm. So let's see what is this lemma is. So the lemma states that, for a given positive integer a and b, so a and b are the positive integer, there exists a unique integers which is q and r. Okay, satisfying a is equals to bq plus r, where r is lesser than b and it is greater than or equals to 0. Yeah, this lemma is quite confusing, but let me take a division and let me explain you. Okay, it's very simple actually. See, here I have considered that 5 divided by 2, right? So let me consider 5 divided by 3, okay, where I'll place 5 outside the bracket, 5 inside the bracket and 3 would be outside the bracket. So the nearest number for the 5 is, in the 3 table is, of course it is 3 ones are 3, because 3 twos are 6, which is more than 5. So I'll write 1, 3. So we got a remainder as 2. Now here they are given that for a given positive integer, see in integer we are having negative and positive, right? But here we are considering only the positive integer. It is very important. So in this the positive integer is 5 and 3, which is a and b. So there exist unique integers q and r. So q and r is nothing but the quotient and remainder. So here the quotient is 1, okay, and I can write as q, and the remainder is 2, which is r. Okay, from this I can write the statement, or I can write an equation which is this: a is equals to bq plus r. A is nothing but the dividend, so I can write as 5 is equals to the bq plus r. Okay, so I can write as 5 is equals to, b is nothing but what? It is a divisor which I took as 3 into q is a quotient which was 1 plus remainder is 2. Okay, so if you observe here, you are going to get 3 into 3 is 3 plus 2 is 5. That's it. It's very simple, right? We can also see here remainder was 2, right? It is always lesser than the divisor and it can be greater than or equals to 0, but it is lesser than the divisor. So that's what the statements say. Okay, with that statement we are going to create the algorithm. Okay, so this is the algorithm. So let's see what is this algorithm states. See, by applying the Euclid division lemma to C and D, here they are taken the C and D, here they are taken A and B, that's it. The same thing, only the variable has been changed. Okay, where C is greater than D. So of course the C is greater than D means C would be dividend D is a divisor now. So we find the whole numbers Q and R. Okay, so we'll find this Q and R, which is a quotient and remainder, such that what we will get? We will get C, which was a dividend, is equals to the dq plus R. Okay, so the C was a dividend, so I can write like this. Now this remainder is, of course we know it is lesser than the divisor, or it is greater than or equals to 0. But sometimes we are going to get the remainder as 0. For example, let me consider 20 divided by 5. Okay, 5 ones are 5 fours are. Now you are going to get the remainder as 0, right? So such way here also sometimes you may get R is equals to 0. Then what will happen? Then the D is nothing but the divisor which we took is a HCF of C and D. Okay. Then if R is not equals to 0, for example, I took note that here the 5 divided by 3, here the remainder was 2, it was not equals to 0. For such case, if R is not equal to 0, then what will happen? We are going to apply the division lemma again. For what? For the D and R, the new remainder, the remainder which we got, and for the divisor we are going to apply. Okay, so this is like solving a case actually. There will be two criminals or two suspects. So we are going to find who is a real criminal is. So let me show you with the example. Okay, then you can understand it. Okay, so here the D and R will be new dividend and the divisor. So again we are going to apply the lemma until you get the remainder as 0. So if you get the remainder as 0, the divisor will be HCF. So why HCF? Of course yes. Why? Because here we are going to use this division algorithm to find the highest common factor actually. So that's the main purpose here. So we are going to use this algorithm to find the HCF for the two given positive integers. Okay, so this is the steps and this is a statement. Using this statement, we are going to find the steps or algorithm.